Okay, let's start with the lab activity involving the batteries. So this is just a simple power supply, if you want to think of it that way. It's just the humble battery, the alkaline battery. Now, all alkaline batteries produce, we say, a nominal voltage, a DC voltage value, volts direct current, VDC, or DC voltage of 1.5 volts. And that's just sort of a nominal value that you'll hear specified. But when you buy them brand new, they actually, you can measure them to be right around 1.6 volts when they're brand new. And all these types of batteries, there's the AAA, that's the smallest, and then these are AA's. And there's a C and a D. Those are your alkaline sizes. They all have the same voltage. The reason for that is basically it's the same electrochemistry. The same, it's like a can full of chemicals, and they all have the same chemicals, so they produce the same voltage. It's electrochemistry. Now, so let's have a look at these batteries, and let's hook them up in various ways so you understand a few things. So first of all, notice in your lab manual that I have this sheet, and I've got boxes where I'm going to have to take data for you. So right now, so what we're going to do is the V1 is going to be the green battery. So let's measure that. So I've got my little digital multimeter. I put that on voltage DC. And then I take the leads and I'm going to hook the red to the red. This is the positive terminal and this is the negative terminal. And we see that we get 1.570. So you write that down right here. Now you can continue without me having to show you this. So we write 1.570. Now notice that, by the way, before I get started on the other ones, check if we can measure them backwards, it's okay. You're just going to get a negative value as you see. See that? Negative. So the digital multimeter also indicates polarity. Okay, now, so let's measure the next one, the blue battery, V2. V2, there you go, 1.566. Okay, V3. Excuse me, 1.594 volts. Okay, there you go. So these batteries are pretty fresh. Okay, so now what you're supposed to do is you're supposed to take these values and add them up here. This is every combination that you can possibly have. V1 plus V2, V1 plus V3, V2 plus V3, and then all three of them in series. So what you do is you just take these numbers and add them up and put them in here. Now, what I'm going to do is so I can get through this video quickly, I'm going to measure them. So how do you hook them up like that? So notice the first one is V1 plus V2. That indicates V1 in series with V2. So what you do is notice that you hook in series. To do a series, we hook the positive to the negative. So that's like stacking batteries. Now what do you suspect the voltage will be? You got any idea what it's going to be? What do you think it's going to be? There you go. 3.137. So that should be close to what you get when you add them. 3.137. Okay, let's do V1 plus V3. So I just need to take this one loose, right? And put this one here. So this is V1 plus V3. And we get 3.164. Okay, now let's do all three of them. So I need another alligator connector. And it doesn't really matter what order we put them in, so I'm just going to leave those like that. So now I've got V1 plus V3 plus. See, these are all in series. See that? And I'm going to hook this positive up to the negative here. And then so now we got all three of them. And what do you get? 4.73. Notice when you go into the 4 volt range, you lose a significant figure there. Okay, now, I did not write down V2. Oh, I didn't do V2 plus V3. Sorry about that. I did not do V2 plus V3, did I? Let's do that. So we got to get V2 plus V3. So that would be the blue battery plus the silver battery. I didn't do that one. So let's do that real quick. I'm doing this out of order. I did V1 plus V2 and V1 plus V3. I haven't done V2 plus V3. Sorry about that. So let's take this one loose here. Notice that this is the blue and the silver. There we go, and we get 3.160. So there you go. That's this. Those are measurements. So you should be able to add those up properly here and see they should agree pretty well. So now, notice in your remote control at home you probably have 2 batteries in there, and you maybe suspect now that there are components in that remote control that require 3 volts. Okay, now, so that's a series arrangement. Now what you need to do is, let's look at something else real quick. Let's take these alligator clips off. Okay, note that these are these are AA batteries. I don't know why I wrote that up there. AA's, so you know. And this is a formal schematic. In other words, if I have one battery and I hook it up like this, if I hook this up like this is a formal schematic for this picture. That's a symbol that's got historic connotations involving what they used to call a voltaic pile, how they used to make batteries back in the 1800s. But anyway, you see you have that's your power supply and that's your voltmeter right there. By the way, let me tell you something real quick that's important to know. You never want to do this with a power supply, a battery, or anything else. You never want to just touch these leads. Why is that? Or just take an alligator, let's say, and just hook them together like this. The reason you don't want to do that, that's called a dead short, because that you're not providing any resistance, and the current would just run wide open, and the chemical reactions would proceed very quickly, and you would just burn up your battery. You would waste it. So remember in the previous video I showed you that a voltmeter, when you're measuring voltage, has a tremendous amount of resistance. So you're only drawing just a little bit of current from the battery. And you can see here that this voltmeter, it's like we could put it's got like an intrinsic resistor inside it's got an internal resistance that's really big. So that keeps you from drawing too much current, so you don't have a closed circuit. Okay, so that concludes the series arrangements. And in this, you're going to have to draw 3 power supplies in series. What would that look like with a voltmeter? So that's what you're supposed to do there, is you're going to have 3 of these in series with a voltmeter. So you need to do that. Make sure you understand how to draw a formal schematic and what they mean. Okay, next we do parallel. Now, in parallel, the voltages do not add. Okay, so let's prove it. So let's stack them up again. We got the green, the blue, and the silver. There we go, V1, V2, and V3. So once again, you still have your values. These values haven't changed. Since I haven't applied a dead short, I really haven't used up any current yet. Those values should not have changed from when we originally measured them. So let's look at the voltages as in parallel. What does that mean? That means you connect the positive to positive and the negative to negative. Now, you might think that that's a dead short, but it's not. Why not? Because we haven't married the poles. There's no current. This is still an open circuit. But now look what happens. Watch what happens here. If I measure the voltage drop across it, you should get the average of those 2 batteries, roughly. So you see that the voltages don't add. So what does that do for you? Well, think about it. The AAA is a really small battery. The AA's are bigger. C's are bigger. You know, they're fatter. And the D's are the biggest yet. It's kind of like just having a bigger battery, more chemicals. It'll do 2 things for you. It'll either last a longer time, or you can supply more current. You know, like if you need some power, you can really supply a heavy current for a short time. So it's kind of like putting them in parallel. They'll just last longer. Okay, got that? So that's V1 and V2 in parallel. Okay, what's next? Next on our list is V1 and V3 in parallel. So all I need to do, check this, I like the way this is arranged. All I got to do is do this. Do this right here. Now we got V1 and V3 in parallel. So I can just, now notice that I can hook this lead. I can hook it either here or here. Why? Well, these are married with a conductor. It doesn't matter where I put it. I can put it here or here. It's like they're soldered together. They're welded together. And I can put this one here or here. It doesn't matter. Here, I'll prove it. Okay, so right here, now we got 1.578 volts. So that's V1, V3 in parallel. Now, watch this. I'll move it over here to show you. Now, it might change just barely, but probably not. Yeah, it did just a little bit. But it will change a little sometimes just because there's different resistances in the wire and stuff. But basically, it's the same voltage. Okay, now what's next? Okay, V2 and V3. So what's that? That's these two batteries, right? Here's V2 and V3 in parallel. So now I'm going to put this here and put this here. And we get 1.580 for V2 and V3 in parallel, right? Now what about all three of them? Well, I can just leave those there. I'll just do this. It shouldn't change any really. It may be a little bit just because all the batteries are slightly different, but basically it'll still be about 1.5 volts, right? So I put this one here, and I put this here. Now all three of them are in parallel. There we go. 1.579. So that's all three batteries in parallel. So you need to finish that up and then put your little schematic here. Okay? Now I've got some questions you can answer. You need to do a little research, read this article, and you know, think about what you're doing here, and finish those questions. Okay, so I hope you learned something about batteries that you didn't already know. Have a good day.